So in this video, we're gonna talk about related rates. So first, what is related rates? Related rates problem involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time. So we have an example here. Example number 1. Air is being pumped into spherical balloon at a rate of 5 centimeter cube per minute. Determine the rate at which the radius of the balloon is increasing when the diameter of the balloon is 20 centimeter. So the first thing that we'll need to do here is to identify what information that we've been given and what we want to find. Before we do that, let's notice that both the volume of the balloon and the radius of the balloon will vary with time, and so are really functions of time. V of t or V times t and R times t. We know that air is being pumped into the balloon at a rate of 5 centimeter cube per minute. This is the rate at which the volume is increasing. Recall that rates of change are nothing more than derivatives, and so we know that V prime of t is equal to 5. We want to determine the rate at which the radius is changing. Again, rates are derivatives, and so it looks like we want to determine r prime of t is equal to t when r of t is equal to d over 2 is equal 10 centimeter. Note that we needed to convert the diameter to a radius. Now that we've identified what we have been given and what we want to find, we need to relate these two quantities to each other. In this case, we can relate the volume and the radius with the formula for the volume of a sphere. So, V times t is equal to 4 over 3 pi and the radius of times t to the power of 3. As in the previous section, when we looked at implicit differentiation, we will typically not use the t part of things in the formulas. But since this is the first time through one of these, we will do that to remind ourselves that they are functions of t. So, you get the 5 is equal to 4 pi times 10 to the power of 2. R prime is equal to R prime is equal to 1 over 80 pi centimeter per second. So let's have another example. A 15-foot ladder is resting against the wall. The bottom is initially 10 feet away from the wall and is being pushed towards the wall at a rate of 1/4 feet per second. So how feet is the top of the ladder moving up the wall 12 seconds after we start pushing? So we have the first thing to do in this case is to sketch a picture that shows us what is going on. We have the sketch here. And we have defined the distance of the bottom of the ladder from the wall to be x and the distance of the top of the ladder from the floor to be y. Note as well that these are changing with time, and so we really should write x times t and y times t. However, as is often the case with related rates, implicit differentiation problems, we don't write the t part just to try remember this in our heads as we proceed with the problem. Next, we need to identify what we know and what we want to find. We know that the rate at which the bottom of the ladder is moving towards the wall. This is x prime is equal to negative 1/4. Note as well that the rate is negative since the distance from the wall is x is decreasing. We always need to be careful with a sign with these problems. We want to find the rate at which the top of the ladder is moving away from the floor. This is y prime. Note as well that this quantity should be positive since y will be increasing. As with the first example, we first need a relationship between x and y. We can get this using Pythagorean theorem. We have x squared plus y squared is equal to 15 to the power of 2 is equal to 225. All that we need to do at this point is to differentiate both sides with respect to t, remembering that x and y are really functions of t, and so we'll need to do implicit differentiation. Doing this gives an equation that shows the relationship between the derivatives. So we have 2x prime plus 2y prime is equal to 0. Next, let's see which of the various parts of this equation that we know that what we need to find. We know x prime and are being asked to determine y prime, so it's okay that we don't know that. However, we still need to determine x and y. Determining x and y is actually fairly simple. We know that initially x is equal to 10 and the end is being pushed in towards the wall at a rate of 1/4 per second, and that we are interested in what has happened after 12 seconds. We know that the distance is equal to rate times time. So we have the end of the ladder has been pushed in 3 feet, and so after 12 seconds we must have x is equal to 7. Note that we could have computed this in one step as follows. So x is equal to 10 minus 1/4 times 12 is equal to 7. To find y, after 12 seconds, all that we need to do is reuse the Pythagorean theorem with the values of x that we just found above. Y is equal to square root of 225 minus x squared equals to square root of 225 minus 49 is equal to 176. Now, all that we need to do is plug into 1 and solve for y prime. So, we have 2 times 7 times 1/4 plus 2 times square root of 176 y prime is equal to 0. 2y prime is equal to 7 over 4 over square root of 176 is equal to 7 over 4 square root of 176. Notice that we got the correct sign for y prime. If we'd gotten a negative value, we'd have known that we had made a mistake and we could go back and look for it. So, the final answer is 0.1319 feet per second.